Okay, here's example 18 with establishing trig identities. So again, if you want to copy this packet to follow along with this packet we've been using in all these videos so far, check the video description here. There's a link, you can click that link, open up this packet, print it out, and follow along if you'd like. So what do we have here? Cosine of negative x divided by cosecant of pi over 2 minus x plus tangent of negative x equals 1 plus sine of x. Okay. So let's go to our general process from the first page in an earlier video. Always start on one side, try to make it look like the other side, and usually start with a more complicated side. Okay. So I think the left side is a little more complicated because on the right side we just have 1 plus a trig function. On the left side we have a negative inside of a trig function, pi over 2, and then another negative and a quotient, an addition here. There's a lot of stuff going on the left. So let's start with the left and manipulate only that side, make it look like the right. Okay, so cosecant pi over 2 minus x, and then plus tangent of x, or sorry, tangent of negative x on the bottom. And then on the top, we just have cosine of negative x. Okay, so three things, or maybe two things, depending on how we're counting, should jump out at us right away. Cosine of negative x and tangent of negative x. You might want to think about even odd properties, right? Even odd identities. So cosine of negative theta is cosine of theta. So whether it's theta or x, it does not matter at all. It's the same thing. And tangent of negative theta is negative tangent of theta. Okay, so whether it's x or theta, whatever, it doesn't matter at all. It's the same exact thing. Okay, so we have those properties here, and also here, it's not written on the paper, but it is mentioned in these steps. Use the basic identities in the table above, as well as the complementary angle theorem if applicable. So this pi over 2 minus x tells us we should use the complementary angle theorem. And remember that says that, well, it says many things, but one of the things it says is that cosecant of pi over 2 minus x equals secant of x. Okay? So cosecant of pi over 2 minus x is secant of x, and here's cosine of negative x, okay? And tangent of negative x. So three things here that we can simplify right away. So let's go ahead and do that. So this equals cosine of negative x is just plain old cosine of x. So that's a really nice property. It's because cosine is an even function. We can just drop that minus sign in there. That's great. That's really, really nice. Okay, just forget about it. And then cosecant of pi over 2 minus x is secant of x. And then plus tangent of negative x. So tangent of negative theta is negative tangent of theta. So whether it's theta or x, it's the same exact thing, doesn't matter. So tangent of negative x is negative tangent of x. So this is really plus negative tangent of x, which means minus tangent of x. Okay? Okay, now where do we go from here? It's not really obvious where to go from here, but one thing we could try is converting everything to sines and cosines. So then we'll have cosine on top, and then 1 over cosine, and down here we'll have a sine over cosine. So that is one way to go. Let's go ahead and go that way. Yeah, there are a few different ways we can go. Let's go ahead and do that. So we want to end up with something, 1 plus sine of x is what we want. So let's convert everything to sines and cosines and hope it all works out. Okay, so that's one way to go. Let's go ahead and do that. So again, that's how we're thinking about it, is we have cosine of x over secant of x minus tangent of x. So let's convert everything into sines and cosines, because we already have a cosine up here, and our result that we eventually want is 1 plus sine of x. Okay, so let's just convert everything to sines and cosines to get rid of secant and tangent. So cosine of x on top still. Secant of x is 1 over cosine of x. Tangent of x is sine of x over cosine of x. Okay. Okay, now we already have a common denominator. That's great. Okay, so that's going to be cosine of x divided by 1 minus sine of x over cosine of x. Okay, like this. Okay, and then so cosine of x divided by this fraction. That's the same thing as saying cosine of x times the reciprocal of that fraction. So take this fraction, flip it. So that's cosine of x times cosine of x over 1 minus sine of x. Okay. So now let's come up here. So let's take this cosine and slap it onto the top here into the numerator. So that's, and what we're going to have then is cosine squared of x on the top And then on the bottom, what we have is 1 minus sine of x. Okay? Okay, now from here, a couple different ways to think about it, but let's think about it like this. What do I want? I want 1 plus sine of x, and that's all I want. Okay, so, well, if that's what I want, let me put it in there. Okay, so here, that's what we're doing is this step, keep your goal in mind, related to this, multiply by 1 or at 0 in a useful way. So keep our goal in mind. What we want is 1 plus sine of x. So let me just toss that in there. So 1 plus sine of x. But, so, you know, 1 plus sine of x by itself, that's like 1 plus sine of x over 1. So having it just by itself is like having it on the top. So 1 plus sine of x on the top. I gotta also put it on the bottom to make that okay. Okay, so we just kept our goal in mind. We looked at what we wanted. We want 1 plus sine of x, and now what we just did is multiply by 1 in a useful way. Okay, 1 plus sine of x divided by itself is 1, so we just multiplied this whole thing by 1 in a useful way. Okay, now leave the top factored, like we usually do when we do something like this. So 1 plus sine of x. And then here on the bottom, what happens on the bottom, let's FOIL that. So 1 minus sine of x times 1 plus sine of x. So we did a lot of foiling but with these earlier examples, but we'll just show the details again. So first, 1, outer plus sine of x, inner minus sine of x, last minus sine squared of x. Okay. Okay, so what we're left with then is, so plus sine of x minus sine of x cancel. So what we have is cosine squared of x times the quantity 1 plus sine of x, all divided by 1 minus sine of x squared. Or 1 minus sine squared of x, I should say. Okay, so now, what can we think? Okay, well, trig function squared, and a 1, and minus sign here, so we can think, okay, well, here's the 1 plus sine of x that we want. Is there, and we just want it by itself, so is there some way that we can cancel these guys together? So in other words, is there some relationship between cosine squared of x and sine squared of x and 1? And yeah, there absolutely is. The Pythagorean identity, sine squared of theta plus cosine squared of theta is 1. Okay. So we've actually used this several times already, and there are a couple different ways we can apply it here. But what we have is 1 minus sine squared of theta. So let's say, okay, or sorry, 1 minus sine squared of x. So whether it's x or theta, whatever, it doesn't really matter. It's the same exact thing. So what we know is that sine squared of x plus cosine squared of x is 1. Okay, so let's subtract sine squared from both sides. So then we're going to have cosine squared of x equals 1 minus sine squared of x. Okay, and we can use this, so 1 minus sine squared of x exactly is cosine squared of x. So then what we have is, so the top is still the same, cosine squared times 1 plus sine of x. And now 1 minus sine squared of x, that is cosine squared of x. Okay, from the Pythagorean identity, that's what we just found out. So cosine squared of x. So then cosine squared of x on top and on bottom, so they cancel. That is great, that's wonderful, because now we're just left with 1 plus sine of x. Whoops. Goofy s's. Okay, 1 plus sine of x, and that's exactly what we wanted, 1 plus sine of x. So check mark, we're done, we're good to go. A couple different things to explain here. First of all, we explained it in all the other videos where we did it, but we'll just explain it again just to be thorough. Why is it okay to do this? Because didn't we say that we should only work on one side and try to make it look like the other side and, you know, don't mix the sides? Yeah, for the identity that we're establishing, we have to stick to that rule. But here we're using a previously established identity, which is sine squared of theta plus cosine squared of theta equals 1. Okay, it's a previously established identity, we know it's true, so we can manipulate it legally however we want, as long as it's a legal manipulation however we want, to be more useful to us. Okay, what we had was 1 minus sine squared of x, so we can manipulate this, subtract sine squared from both sides to get another identity, okay, or really another version of the same identity. So cosine squared of x equals 1 minus sine squared of x. Okay, so that's what we had ended up with here. And again, it's okay to mix the sides for a previously established identity that you already know is true. But for an identity that you are establishing, okay, we're establishing this identity right now, or we were anyway. So, you know, it's not okay to mix the sides. Okay, we can't subtract sine of x from both sides. We don't want to mix the sides together. Start on one side, only manipulate that side, and try to end up with the other side. That's exactly what we did. Okay? But again, for previously established identities, you can mix however you want. Legally, as long as it's, you know, subtract the same thing from both sides, add the same thing to both sides, and so on. So that's exactly what we did here. Okay, a couple of other things to point out. There are a few different ways we could have gone. Here, when we converted the sines and cosines, instead of doing that, what we could have done is multiply the top and the bottom by secant of x plus tangent of x, okay? So that's sort of related to like an example 17, when we multiply by 1 minus sine of alpha over 1 minus sine of alpha, because we had a 1 plus sine of alpha on the bottom. If you didn't see example 17, don't worry about it, but it's just it's a common technique to try is if you have something like this, well, hey, try multiplying by the same thing but with the plus sign instead, or maybe if you have a plus sign here, try multiplying by the same thing but with a minus sign instead. Okay, so it's absolutely not at all obvious to try that, and it's absolutely not at all obvious that that'll work, but it will work, and it is something we can try. Okay, but what maybe would jump out at us a little more is, well, hey, here's a cosine. What I want is eventually 1 plus sine of x, so let me convert everything into cosine and sine, so I can get rid of the secant and tangent at least, and then maybe we'll work on the cosine later. Okay, so that's maybe what will jump out at us more. And again, it's just not at all obvious to multiply the top and the bottom by secant of x plus tangent of x. But you absolutely can do that, okay, because it's really just the same thing as, it's related to rationalizing the denominator. So if you have like 2 over 1 plus root 3, multiply the top and the bottom by 1 minus root 3. Okay, it's really the exact same thing, but instead of 1 and root 3 and a plus sign, you have secant and tangent and a minus sign. Okay, so it's, again, not at all obvious that we can do that, or, well, it's, you know, of course we can do it, we're multiplying the top and the bottom by the same thing, but it's not at all obvious that that'll work. But anyway, that's that. So we could have gone that way. Continuing this way though, if we keep doing it this way, we ended up over here, okay, and then when we're at this step, we said, okay, I want 1 plus sine of x, so let me just toss it in there. So now I have to multiply the bottom by the same thing to make it okay. Another way to think about that is actually, so if we just have this, we can say, okay, cosine squared of x, if I look at the Pythagorean identity, cosine squared of theta plus sine squared of theta is 1, I could subtract sine squared of theta from both sides, and I end up with cosine squared of theta is 1 minus sine squared of theta. So that actually probably would have been a better way to go. So what I was saying is if we have cosine squared of theta, cosine squared of, or really x, in our case it's x for this problem, cosine squared of x over 1 minus sine of x. Okay, so we eventually were at this step here, cosine squared of x over 1 minus sine of x. We know from the Pythagorean identity, sine squared of theta plus cosine squared of theta is 1. Okay, so sine squared of x, it's actually that thing I just erased, plus cosine squared of x is 1. So I can subtract sine squared from both sides, and I end up with cosine squared of x is 1 minus sine squared of x. Okay. So cosine squared of x is 1 minus sine squared of x. That comes directly from the Pythagorean identity. So then we can continue with this and say, okay, 1 minus sine squared of x on top, 1 minus sine of x on bottom. And then what we could do is factor the top, because remember, it's a difference of squares. So remember, 1 is the same thing as 1 squared. So it's like factoring a squared minus b squared is the same thing as a minus b times a plus b. Okay, so you can factor the top. Okay, if you factor that, you'll end up with 1 minus sine of x times 1 plus sine of x, and then the 1 minus sine of x cancels with on the top and the bottom, and you'll just end up with 1 plus sine of x again. Okay, so anyway, another way of thinking about it, so that's really 3 different ways for this one example here. So maybe that way we just talked about might have been a little simpler than this, but it doesn't really matter. So the point is that there are multiple ways to approach it, and none of the ways is really incorrect. Okay, some might be more complicated than others, some might be more difficult to realize than others. But as long as you do, perform legal manipulations, just start on one side and only manipulate that side, and make sure that you do, legal manipulations like multiply the top and the bottom by the same thing. And if everything works out okay and you get to your desired result, there's really no one right way to do it, generally speaking. Okay, so that's one of the correct ways. If you do it like that and you get the correct result, that's one of the correct ways. Okay. So really, just the point is there may be multiple ways to approach it, like we've seen with a few of the other examples now. So anyway, that's example 18 with trig identities. Establishing this identity here showed that this mess equals 1 plus sine of x, and that's what we got. So check mark, we're good to go. And that's example 18.